Hi, I'm Jeff Yurek. I'm the head of marketing here at Nanosys, and I'd like to show you some demos on quantum dot technology. So come on in.
And so what's the latest?
The latest, well, this year, one of the big stories we're talking about is quantum dot manufacturing. We're part of a company called Shoei Chemical, which is a really powerful, great manufacturing company. We want to talk a little bit more about the manufacturing capabilities that we have and how quantum dots are made. So a lot of people already know the main sort of superpower of quantum dot technology is the ability to do precise spectrum engineering. What we mean by that is creating any color in the visible spectrum using the quantum confinement power of quantum dot technology. So let me take this actually back a little bit and pause it. So if you don't know, quantum dots are tiny semiconductor nanocrystal materials. They're between the size of a water molecule and a virus. So they're really, really tiny. And they have this unique ability as a semiconducting nanoparticle. By changing the size of the crystal, we control the band gap of the semiconductor. We control the electrical properties of the material, which changes the color of light that it emits. So in a display, we pump them with blue photons from a blue LED. Blue photons are very high energy. They charge up the quantum dot, and it burns off some of the energy. In the case of a red photon, burns off a lot of energy, and you get a lower energy, longer wavelength red photon. And smaller quantum dots emit blue light or green light.
And you're able to do all this very precisely somehow?
Very precisely, exactly. So we're showing here our real quantum dot vials. These are actual quantum dot materials sitting on top of blue LEDs. And we're showing every 2 nanometers here, and I'll pause the video again. So 521, 523, 525, all the way up to 640 here. We can make any wavelength, even in between, with plus or minus 1 nanometer peak wavelength accuracy. So very, very precise control of the color of light.
So that's why it's nanotechnology, because you are down to 1 nanometer?
Yeah, exactly, yeah. Very, and even smaller changes in the size of the quantum
And so
dot.
it's so precise, even though it's a big portion of it.
Exactly, trillions of crystals, right? And so why does this matter for displays? Well, displays, as you probably know, produce red, green, and blue light. They make all the colors we see just by mixing red, green, and blue light. So when a brand comes to us and they want to use quantum dots, they give us a color gamut spec. They say, I want to hit more than 99% of, let's say, DCI-P3 color gamut, which is a standard color spec for Hollywood movies, for example. They have a color filter that they're using already for their LCD display. And this is the filter at the front of the display that segments out the light from the backlight. One thing we've learned over the years, display maker never wants to change the color filter. It's too costly, right? So they pick a different phosphor, they have to live with whatever the spectrum is. But with quantum dots, we can actually tune the peaks of red and green to give them the exact color they want. So for DCI-P3 with this filter, you get 521 and 631, and you get 100% of DCI-P3. The other factor here is the brightness or the luminance of the display. So it's important to have the longest green and the shortest red that you possibly can. The way that nits are measured, it's a measure of brightness, takes into account the photopic sensitivity of the human eye, which peaks at about 550 nanometer wavelength of green. So you want to be closer to that to have more apparent brightness while still covering the color gamut.
How does a TV or something gets this and this? Where do you put it?
So that's the next question, right? So first you come to us, we figure out what the recipe is, you order off the menu here, right? Then you go to our big factory in Idoshima, Japan, and this is a real shipping drum of quantum dots that we ship out of our factory.
So it's the barrel.
This is the barrel, and this is the factory that they're made in here in Idoshima, Japan. It's a really, really beautiful part of Japan, in the southern island of Japan. And we have capacity there for more than 40 million square meters of TV, 40 million TVs, basically.
Does this cost more than oil barrel?
It probably costs more than oil barrel. This is a 50 kilogram drum of quantum dot technology. One of the amazing things when you look at that little vial of quantum dots, inside this 50 kilogram drum will be trillions and trillions of quantum dot crystals. They all have the same size, plus or minus a couple of atoms. If it's more size difference than that from crystal to crystal, then the color won't be pure, right?
What's the size of an atom there? It's much smaller than a nanometer.
Oh,
Oh, what do you call it? It's like
just like 6 to 8 nanometers in diameter, or the size of the crystal. So incredibly small diameter crystals. Really.
And so somehow the whole delivery is exactly to spec what is needed, and
Right.
it's not going to be lost in quality.
No, exactly. We have an amazing process, actually. We're able to shine blue light into the reactor while the crystal is growing, right? And we see the wavelength shift as the dot gets larger, as it's growing. And when it gets to the wavelength we want, we change the temperature, we stop the reaction, right? So we're able to really precisely control the reaction. So that's great. I've got a drum full of like glowing quantum dots, right? How do I put that in a display, right? Well, that's where it comes to our partner. This is one of our coating partners here, Bredi. They're joining the booth with us this year. And these are quantum dot enhancement films. And see if I can pull one out here for you. This is a thin 2 layers of PET plastic with quantum dots in a resin layer. It's a roll-to-roll process with a slot die coating. And you can see if I shine some UV light here, it's turning green because this is UV and not blue. But you can see it's converting the UV light into red and green. There's red and green quantum dots in here. And inside the LCD backlight will be a blue LED. And that's where you get your blue.
Nice. So this fab looks amazing. And with the acquisition, is there like the next step in terms of quality, quantity? Are there like new fabs happening?
Yeah,
or?
I mean, Shoei is just a master precision manufacturing company. They've been around since the 1950s, making nickel powders and pastes for things like multi-layer ceramic capacitors. And they just have tremendous expertise in manufacturing with really high precision and massive scale. So yeah, it's great. It's been a great partner and now a great company to be part of.
And I guess they're building specifically for this application, like
Yes.
the whole systems.
That whole factory is for quantum dots. Yeah, exactly. It's the largest quantum dot factory in the world, actually. So next up here, we have another new emerging application for quantum dots, and this is automotive. So if you've been taking videos around the show, I'm sure you've seen a lot of automotive demos, right? Automotive will soon be the number 3 application on an area basis in the display market. Cars have more displays and they're getting bigger, and it's a huge growing opportunity. So we're all trying to get in on it, right? So automotive brands tell us they actually want a lot more color than what they're getting today in the displays they have. The reason for that is in a dark room, display might have great color, but as you increase to moderate and then even indirect sunlight outdoors, which is a very common condition that you run into with a car, your display starts to wash out. You lose contrast and you lose apparent color saturation. And so that's where quantum dots come in. You see here a standard LCD. This is very similar performance to what you'd see in a Tesla Model 3. And then here you have a quantum dot enhancement film LCD. It's got 114% of the NTSC color gamut on the right, and this is only 97% of the NTSC color gamut. So a lot of extra color so that when you're under high brightness lighting, and this, by the way, is 10,000 lux from these movie lights up here, 10,000 lux of ambient, which is like a cloudy but a bright cloudy day. So very common condition for a car.
Nice.
So
more colors in the future cars.
Yeah, exactly. And one of the big changes for us is having the ability to pass the reliability requirements for cars. Cars are in very cold places, they're in very hot places, they need to last for a long time and be reliable. Car brands want to see us pass over 1,000 hours at 105 degrees centigrade, right? That's very, very hot. It's above,
That's boiling.
Above boiling, right? So yeah, if you think your car is 105 degrees centigrade, don't get in your car. It's really an accelerated.
It's to drive through a volcano. Or what?
Yeah, something like that, right? It's extreme, right? You can see luminance and white point shift here. So we're able to pass all those specs. We're excited. We've got our first big design in from a major car maker. We'll be rolling out this year. And again, if you look around the show floor, all these mini LED automotive demos you see, most of those are using quantum dot enhancement film. So it's a really exciting market for us.
And they're getting much better black levels, much better contrast,
Yes.
at much lower power.
Exactly, with the mini LED backlight, it's a really, really exciting thing. So here we have another example. Maybe you've heard some of this story in the marketplace. Some TV brands have been accused of selling quantum dot TVs that are labeled with quantum dot on the box, but which do not contain quantum dots. And that's true, actually. And so we wanted to show what that looks like. We're working with TUV Rhineland, with the brands and other standards organizations to help the industry develop some standards so that they know when they label something quantum dots, it should have quantum dots inside. So on top, we've got a full quantum dot TV. On the bottom, we've got a TV that says QD on the box, which has almost no quantum dots inside, just a teeny amount of quantum dots in this TV.
It's not like you're the only ones making quantum dots, right? So it's okay that there could be other ones, but sometimes they just don't use any.
They just don't use any, yeah, exactly. So we wanted to point that out to the community.
That's not fair.
It's not fair. So yeah, just this last week, TUV Rhineland announced a new spec for a real quantum dot TV. And one of the cool things you'll see here is that TVs that are labeled quantum dot TV, but which don't have quantum dots, actually score much lower. Here's the slide here on the review, right? Ratings.com, on average, 1.5 lower mixed use score on TVs that are not telling the truth about what's inside. So you don't even have to wait for the TUV Rhineland spec. You could just follow the reviews, make sure you're getting
And as you're saying right here,
yeah,
it can be really affordable to get real quantum dot stuff, huh?
no, these TVs are the same price. So we just want to make sure the consumer knows, right? Make sure you're getting the real, genuine article. Otherwise, you're getting ripped off.
It's so awesome that the whole world can get access to this beautiful displays for affordable prices.
Exactly.
That's really awesome.
Doesn't have to cost a lot. Exactly. That's
500
one of our big
bucks.
points.
Like, that's so cool.
65
This
inch.
is
with great
65
color.
inch, 4K, beautiful.
Right here we have an award-winning demo. This year we got another blue ribbon for the People's Choice Award for a metrology demo. This is a collaboration with blurbusters.com, and we're showing the speed advantage of quantum dot technology. So on the top here, I don't know if your camera will catch it, but if you look at this white bar, it's breaking up into red. This is running in black frame insertion mode, which means the backlight is flickering on and off. And when it flickers, the red color in the backlight continues to ring even when the LED is off. And that's why you see this red. If you don't see it here, you can see it on the meter. This is actually a little tester here, and so you can see the tester stops working when I pull it off. And try to put it back on here. Let it settle. And what you see is, oh, I didn't get it on there right. Okay. The red, this is the frame opening, right? And then this is the LED turning off, and the red is ringing after the frame is supposed to have closed. And that's no good, right?
That's
we want
stressful.
to have nice, crisp on-off. This is quantum dots on the right hand.
That's
right?
relax.
Yeah,
Yeah,
exactly.
that's great.
It's
And you've been talking about comparing with the phosphor for a while.
for a while, yeah. We actually wanted People's Choice Award for this last year. We wanted People's Choice again for this year. So the audience is really appreciating this. And maybe you showed this last year, but yeah, you have the slow red on the left and then the QDEF on the right.
Nice. Looks like a comet.
Yeah.
Bleeding comet.
This is another metrology demo here. This is showing a new metric called gamut rings. We're seeing in the video right now how you measure this new way to measure color volume with 602 data points gathered. And it's a way to understand the color, the chromaticity, and the luminance together in color volume. This is a QD OLED on top and a white OLED on the bottom, right? On top, 99% DCI-P3 chromaticity gamut, if you're familiar with this horseshoe chart, right? The bottom, 98%. Basically the same, right? The resolution, 140 ppi for both. The peak luminance, 1,000 nits and 973 nits. Basically same resolution, same luminance, same chromaticity gamut, same price actually. But there's a difference that you see with your eye, right? And that's explained by gamut rings. So on top, 98% coverage of the DCI-P3 color volume at 1,000 nits peak luminance. On the bottom, 52% coverage of the DCI-P3 color volume at 1,000 nits. The way that gamut rings works is the middle of the diagram here is the black, right? Coming out of black. Each ring is 10% higher luminance. So the first one is 0 to 10, 10 to 20. The last one is 90 to 100% luminance, right? And you see this is filled in with color from black to the brightest bright. On this side, you can see in the black, it's good. As you get into the mid grays, and then here about halfway up, it turns gray. Gray is the target. So it does go to 1,000 nits, but it's essentially black and white above 500 nits, and that's what that's telling you. And that's that difference, how bright that red is versus that red. It can do bright, it can do color, but it can't do bright and color at the same time. QDOLED is RGB additive all the way up and down.
Nice, so that's like computer monitors?
Computer monitors, yep, and TV is also white OLED versus QDOLED, the same story. Over here, we have an example of one of the most exciting quantum dot products we found out this year. Quantum dots can be found in the M4 MacBook Pro. It's a really beautiful product, and so we thought it would be cool to show what a really beautiful product with quantum dots looks like here at the show floor. You can see we're showing here the previous generation MacBook Pro, which uses the KSF phosphor, the new generation, which uses quantum dots, and then comparing it to the tandem RGB tandem OLED iPad Pro on the right. Now, you'll notice they all have similar color gamut. It seems like Apple's done a great job of tuning the color to match, 99% P3, 1600 nits peak luminance. One of the things you see on the notebook, though, is it has 1000 nits at full screen white. So it can get really, really bright. It also has a little bit longer battery life than the previous generation. And are the quantum dots responsible for that? Probably not. But it shows you that the quantum dots are a very, very efficient system. It'd be very challenging to make those improvements if you didn't have an efficient.
I have an M1 and I'm very happy with the quality, but that's 4 years ago.
Yeah,
right?
yeah.
And stuff is happening.
Stuff is happening, so it keeps getting better. And we think even compared to the tandem OLED, which is an award-winning, amazing display, the QD Mini LED notebook display holds up really, really well. I mean, it's very hard to tell them apart from most scenes.
And a lot of people are doing great productivity on these devices.
Yeah.
And they're enjoying great quality.
Yeah, they're awesome. And I'll show you one more advantage for the QDs on the MacBook Pro. So what we're showing here is something called the cyan flash artifact. And it's another example of that slow phosphor problem. So on the left, you see the KSF screen. It looks a little bit cyan colored, a little bit bluish, and the QD screen is white. Now, on the screen you saw over there with KSF, you saw a red color artifact. Here you see cyan, and that's because it's not the closing, it's not the turning off that you're seeing the turning on. So in this case, when the white box goes into a new mini LED zone, the LED turns on, you get blue and green within a few microseconds, but the red takes about 8 milliseconds to warm up. And so the frame is almost already gone before the red is even warmed up to make white. So it's one of the great advantages of the new quantum dot system here.
And here at the show, I went to the Samsung booth before.
Yeah.
And there's something amazing in there.
Yes.
Right? And maybe other places at the show.
Yes.
Can you talk about what's amazing and what's kind of like next gen that you might be involved with?
Absolutely. So one of the things we're most excited about.
I don't know if we're allowed to go there now. Do you think we're allowed to talk there on video?
It's pretty far away.
Otherwise, I'll cut in my footage.
Okay,
right
cut
here.
in your footage. That's the way to do it. So yeah, Samsung is showing electroluminescent quantum dot, or QDEL, sometimes called nano LED, sometimes called AMQLED. Some other brands are calling it AMQLED here. We see a tremendous amount of activity in this area. We're investing very heavily in it. Samsung shows, I think, an 18-inch 400 nit screen. Last year was 250 nits. So you can really see really rapid, really meaningful improvement. We're getting very close to commercialization. I think if you talk to the brands, you're hearing anywhere from 2 to 4 year kind of time frames. So take those with a grain of salt as always, but really rapid progress. We're working really hard on it, and it's incredible.
What's the selling point on these displays?
So it's an OLED, right? But inorganic, right? So it should be more rugged, brighter, flexible, solution processed, and that's the key thing. It's easier to make than an OLED. We think you can make it in open air without using the vacuum process, without using all that expensive tooling. Now, if you want to catch up to LCD ever, which OLED is not doing right now for TV, right? Nobody's building a new OLED factory. It's too expensive, right? If you want to catch up, you have to have low cost. You have to be able to build a factory for less. And if you want to catch up to LCD over time. And so we think QLED is going to be the application that ultimately is able to catch LCD.
And it looks beautiful at this show.
Yeah.
And it's doubling brightness every year, nearly, it looks like.
That's what we saw year over year. Yeah, we have 2 data points.
Next year it might be 800.
Let's see.
But what's the big challenge to get it to mass production?
Just getting it to mass production. Right now, the red and the green from everybody are really close to MP ready, really almost matching OLED performance today. Just like OLED, it's all about the blue and improving the blue lifetime and the blue performance. And we're working very hard on that, and we think we'll get there soon.
You just double the amount of blue in the display somehow?
Well, OLEDs do kind of do that. The blue pixel's often larger than the other pixels, and it's one way to do that. So yeah, maybe that's part of the solution. We'll see.
Are you involved with some of the oxide advancements or the new crystal?
The backplane stuff? No, that's not in our wheelhouse. Yeah, it's great.
Because you're involved with the LCDs, with the OLEDs.
Yep.
And now the
QLEDs, yeah.
QLED.
And QDEL. We're also involved in MicroLED. We're shipping quantum dot color conversion materials for use on top of MicroLED. And you'll see that at a few booths here. If you see the Play Nitride booth, they have a 500,000 nit RGB MicroLED display with quantum dot color conversion. Raysolve has something similar. Innolux is showing a TV, 100-inch TV with QD color conversion. So yeah, MicroLED is part of the story as well.
And so they have a pattern on the front of the MicroLEDs with what could be your quantum dots as a pattern somehow.
Well, they put down all blue or all ultraviolet LEDs, and then they inkjet print or pattern with photolithography red and green quantum dots on top. And the quantum dots absorb the blue light or the UV light and just down convert it right at the pixel level.
Nice, and somehow it's aligned perfectly. And then you just tweak it, and then it's the right colors coming out?
Yeah, it's printed right onto the LED, so there's no alignment to do. Yeah, I mean, it's all about the printer accuracy, I guess.
Nice. And how was this show in general? Because you're a lot involved with the SID Display Week, right?
Yes. I'm the head of marketing for SID Display Week as well. It's a great show. We had a higher attendance than last year.
Actually, the highest ever, I heard. Isn't it higher than 2019? I heard it's 10% more than pre-COVID.
Interesting. I have to go check the numbers. So
it's because of your job.
I don't want to claim anything
you made
here.
Sure more people came.
I'll take your word for it. That's awesome if that's true. But yeah, it felt like a great energy all week, and we love the show, man. It's the best place to talk about cutting edge displays and meet people like us and learn about new technologies, and we love it here.
Did a lot of media come and get a tour with you?
Yeah, we had about 50 press registered for the show, and we had a great media reception here at the booth as well. Yeah.